Welcome back. We have already discussed the standard equation of a circle. Now let's apply it in an example. Write a standard equation for the circle of radius 2, so a equals 2, centered at 3, 4. Centered at 3, 4. Now let's review the standard equation of a circle, which looks like x minus a squared plus y minus k squared equals a squared, and this is the equation of the circle which has a radius of a, so a is the radius, and centered at hk. Now we need to apply this equation into this problem, and you can see that you just need to subtract the abscissa of the center from x, so we subtract x minus 3, and you need to square it, and then add y minus the ordinate of the center, so it's y minus 4 squared, and that equals to 2 squared, which is 4. Now that is the equation of the circle which has a center at 3, 4 and a radius of 2. Now if an equation for a circle is not in standard form, we can find the circular center and radius by first converting the equation to standard form. The algebraic technique for doing so is completing the square. Let's see an example for this. Now find the center and radius of the circle x squared plus y squared plus 4x minus 6y minus 3 equals 0. So this is another equation for a circle, and now we want it into the standard form. I wanted to transform it into the standard form. First, we start with reviewing this, that x plus the constant number squared is x squared plus 2xc plus c squared. Now how do we use it in this problem? We can see that there is a x squared here and there is a 4x, so it will be something like x plus 2 squared, but x plus 2 squared equals to x squared plus 4x plus 4, and we don't need a plus 4, so we will subtract 4 from it, and it's not equals to this anymore, and it will look something like this: x plus 2 squared minus 4. And this is the exact same thing that we have here, and we will do it with the y too. So we can see that y squared is here and minus 6y is here. So we need to divide the coefficient of the single y by 2, and we get the constant number we need to add to y or subtract from y and then square it. So if we divide it by 2, the minus 6, then we get minus 3. So y minus 3 to the second power equals y squared minus 6y plus 9. But we don't need the plus 9 here, so we will subtract 9 from it, and it looks like y minus 3 equals y minus 3 to the second power minus 9 equals to this. And now we need to add these things, and it will look like x plus 2 squared plus y minus 3 squared minus 4 minus 9, and then we have a minus 3 here, so we need to subtract 3, 2, and this equals 0. Now we add 4 plus 9 plus 3 to both sides, which is fast calculation, 16. And now we have that x plus 2 squared plus y minus 3 squared equals to 16, which is 4 squared. Now that's great, because now we have a form of the standard equation of a circle, and it's the exact same thing that we have started with. And now we know that it has a radius of 4. It has a radius of 4. So A is 4. And we know that the center lies at minus 2, 3. So it looks like, now I'm trying to sketch up this here. We need a Cartesian coordinate system. This will be the y-axis, and here's the x-axis. And now we can see that minus 2 is here, 3 is around here, and so here is the center. Now here is the center, and we want a circle with a radius of 4, so we need to go down, this is the origin, and we need to go down 1. So here is another point of the circle, and at 2, 3 there's another point. We go up 4 units. Now this is 7. Here's another point, and another 4 units backwards. That is minus 6, and here's another point. And the circle will look something like this. Oh, it's just messed up. But you can see that it has the radius of 4. So this is A, and centered at minus 2, 3. I hope you understand this. I just need some space for my next topic. Just a second. There we go. Now let's talk about parabolas. We will discuss the geometric definition and properties of general parabolas later. Here we look at parabolas arising as the graphs of equations of the form y equals a times x squared plus bx plus c. So consider a really easy one as y equals x squared. And some points whose coordinates satisfy the equation are, for example, 0, 0, the origin, and 1, 1, or minus 1, 1, with 2, 4, minus 2, 4, and I don't know, 3 over 2, 2, with 9 over 4. So let me sketch up a parabol. This y equals x squared parabol in this Cartesian coordinate system. Now we know that the origin is a point of the graph, and 1, 1 and minus 1, 1 is also points of it. So we know that these are points. We know that 3 over 2, 9 over 4, which is just a bit bigger than 2, is also a point, and 2 and minus 2, 4 are also points of the parabol, of the graph. Now we can connect it with a smooth line, and this is going to be our y equals x squared parabol. Now we are going to continue the parabols in the next video, but I'm running out of time, so see you very soon.